Hello Finxters and welcome to a new Pandas tutorial. In this tutorial we will learn how to read and write flat files with Pandas. First we will learn what a flat file is, and then we will learn how to read a flat file using Pandas functions read CSV and read table, and we will see how these functions differ from each other, and we will see how to write a data frame to a CSV file. So first of all, we will start with what is a flat file. Basically, a flat file is just a text file that stores some sort of data and that has no hierarchical structure. It is composed of one data set and it has no text processing or structure markup. And typical formats for flat files are .csv, .txt, and .xml. For this tutorial, we will use two different flat files, a CSV file and a text file, which both contain the same information. And yeah, this is how they look like. Here we have the CSV file, and over here we have the text file. And as we can see, they both contain the same information. It's just information about three people, the people's age and the number of children that these people have. And yeah, now we will head over to the coding section and see how to read a flat file with the two functions read CSV and read table. We will start with read table, and to do so we first have to import Pandas. And then we say pd.readTable, and inside this function we state the name of the file that we want to read. We start with the CSV file and we assign it as a string, and this is how it's called. And we do not have to set the path of this file here where it's stored, because in this case it's stored in the same working directory. However, if we have it stored somewhere else in our computer, we would have to state the path of this file, but now we don't. And if we execute that, we can see that we created successfully a Pandas data frame. Yeah, but at the moment the output is a bit messy. As we can see, we still have the semicolons which separate the values, and it doesn't really look that nice. But we can change that by telling the program for which separator to look for. And we achieve that by applying the sep parameter. So again, pd.readTable, again the name of the file, and we apply the sep parameter and set it to a semicolon, because that's the separator of this file. And if we execute that, we see that now we have a bit more cleaner data frame, and the data is really separated nicely from each other, and we don't have these semicolons anymore. And now we will do the same with the read CSV function to see how that works. Again, pd.read CSV. Again, the name of the file, example.csv, and executing that again gives us this pretty messy output with the semicolons. But we can just copy what we just had there and again apply the sep parameter and again assign it the string of semicolon, so that we get the cleaner data frame here. And as we can see, both functions work the same way, the read CSV function and the read table function in this case. And now we will read in the text file, which is called example.txt. And we start with the read table function. And again, we have to assign the name of the file as a string. This time it's example.txt, and we directly set the separator parameter to avoid the messy output. And as we can see, this reads in the data frame the same way as before. So it doesn't matter here if it's CSV or TXT, because it contains the same information, or these two files contain the same information. And yeah, we can do the same with the read CSV function again. Again, stating the separator here, semicolon. And yeah, this also creates the same data frame. And if we have a look at that, what we have just done, it looks like the read table function and the read CSV function are working the same. And if we have a look at the documentation, we see that they are indeed almost identical. The only difference actually is that the default value for the separator parameter, which we have seen, the sep parameter, the default value is different for these two functions. With the read table function, the sep parameter is set to \t, which stands for tab stop, and the read CSV function, there the sep parameter is by default set to comma, because it's CSV stands for comma separated values. And yeah, apart from that, these two functions do not differ from each other. You might think, or one might think, that the read CSV function is meant to be used for reading CSV files only, but we've already seen that we can also read in TXT files, for example, so it also works for that. So for the rest of the tutorial, we will use the read CSV function instead of the read table function, because it's like more common sense to use the read CSV function, but everything that we do with the read CSV function can be conveyed to the read table function. And yeah, the read CSV function provides us with lots of other parameters apart from the sep parameter. And we will start with the use calls parameter, where we can specify which columns we want to read from the flat file. For example, we might not want to read all the columns that the file provides us with, but only specific ones. And this is how we achieve that. pd.read CSV. Again, we read from the CSV file, set the separator, and we apply the parameter use calls. And here we the parameter expects a list of columns that we want to include in our data frame. Let's say we only want to have the name column and the children column. And as you can see, if we do that, we only get these two columns, and the age column is now missing because we didn't apply it to our use calls parameter. Another parameter that we can use is the index call parameter, and we use this parameter if we want to set a specific column of our data frame as the new index column. For example, we could set here the name column as the index column. And this is how we do it. Again, we also set the separator, and we say index call equals name. So the name column is now the index of the data frame. And yeah, we could also, for example, change the column names, and we could, for example, transform the name column to be labeled person, and the age column to be labeled years, and the children column to be labeled like pets, for example. So to do that, we first of all have to apply the header parameter. and set it to 0 because we already have a header in our data set and we want to get rid of that. So we have to set this to 0. Let's do that. So header equals 0. And we have to tell the program what the new column labels should be. Therefore, we apply the names parameter, which expects a list of the column labels. And here we apply person, years, and pets. And if we execute that, we see that we get this data frame where the header column labels have changed, and these are the new column labels, as we can see here. And yeah, now we will see how to write a data frame to our own CSV file. Therefore, we first of all have to create a data frame that we want to use. Let's just read from the CSV function the example data sets. Yeah, so we now have assigned this read in data frame to a variable df, so we can now write it to a CSV file. And yeah, the approach is actually pretty straightforward. We just have to say df, which is the data frame that we just created, and now to CSV. And inside here we state the name of this new file as a string, and we just call it new underscore file. And now, which is very important, .csv to tell the program, okay, we want to create indeed a CSV file here. And if we execute that, we don't get an output, but in the working directory, so in the same folder, basically a new file was created, new file.csv. And if we open that, we can see this new file with the information from the data frame. And we see that by default the values are separated by a comma, and we will now learn a bit about the parameters of this function, and we could here as well apply the sep parameter, which sets the separator of the CSV file. So we say df.toCSV like before. Again, new file.csv. So this file that we just created now gets overwritten basically, and we state the separator to semicolon. And now, as we can see, the values are now separated by a semicolon because we changed the separator to the semicolon value. We could, for example, also get rid of the indexes. Therefore, we could set the index parameter to false. Maybe we can just change or add this line a little bit. And here we add the parameter index and set this to false. So we get rid of the indexes because in some use cases we might not want to use them. And now we've executed that, and now we should see that the indexes, like they were here before, they are now gone. So we have this new CSV file without the indexes. Another parameter that we could apply here is the header parameter, which we can use to change the headers of the CSV file. And maybe I can just again change this line here to change the headers, because right now the headers are name, age, and children. And like with the read CSV function, we might want to change them to person, years, and pets, for example. Could be anything, it's just a random example. So the header parameter expects a list of strings here, and yeah, so I just state person, years, and pets. And if we execute that, then the new file should have the new headers, person, years, and pets, as we can see. So this worked successfully. Alternatively, we could also set the header to 0, because the header parameter doesn't necessarily expect a list of strings. It can also be set to 0, for example. So this way we get like no header at all, no header row, and it's just the values themselves. And again, we don't get an output, but just the file has changed if we do that. And as we can see, the header row that we just created is now gone, and we now only have the values of the data frame in an own CSV file. So yeah, that was the tutorial. We have learned how to read flat files using 2 different Pandas functions, and we saw how they differ from each other. We also applied their various parameters, and we also saw how to write a data frame to its own CSV file in several ways. And that was the tutorial. I hope you liked it. I hope you learned something, and I see you in the next one.